Good evening, everyone. Am I audible? Am I audible? You can write. Okay. And is my screen visible? Okay. We will wait for a few more minutes because the strength is right now 10. Okay. So we'll wait for a few more minutes, and if uh, if no one joins, then we can start. So we'll just start within 5 minutes. Okay. Okay. So does one have any doubt from the last live session or anything as such? If you have any doubt, you can unmute yourself and you can speak up. Okay. Okay, let's start the session. Um so, welcome back to the second live session of Solar Energy Engineering and Technology. Myself, Soumya Tiwari. I'm PhD scholar at Department of Sustainable Energy Engineering, IIT Kanpur. So, in last week, we discussed about week one content, right? So, in this lecture, what we'll discuss is week two content and the due date, just to remind you, the due date for submitting assignment for week 2 is on 7th of this August. So what we'll do is, for the first few minutes, say 15 to 20 minutes or maybe half an hour, we'll quickly go through the content of the week 2. So if anybody has not watched the lecture, they will have some general idea about what was the week content, and then later on, for the rest of the remaining time, we can solve the question as we have done in the previous lecture. Okay. So So the agenda of this module 2, week 2, was for you to develop a basic understanding of different parameters that will be used to investigate the different solar thermal devices. So in this week, you might have seen about seen several angles, several parameters, how they are defined, what are their meanings. So the purpose of this week module is to just develop an understanding, and note that there are several formulas given in this week 2 content, but you don't have to mug up or remember all those formula. those formula I will tell you in the upcoming slides, which formula you have to remember, which you have which you need not to remember. uh, so let's start the session. Okay. So, in the last lecture, we have discussed how solar radiation is propagating through the extraterrestrial, between Sun and Earth, how it's propagating from extraterrestrial to terrestrial region, on and then to on the surface of the Earth. So, uh, it's not like the distance between Earth and Sun is constant throughout the year, right? So there is variation of the solar radiation flux, and how this variation takes place. It is given by a mathematical equation, um, that you can see here. Uh, okay, just a minute. Okay, my pen is not working. Just give me a minute. Uh, okay. Okay, someone is saying voice is not clear. Okay. Okay, is my screen visible and my audio is clear, or is it not? You can just write in the chat box. Okay, fine. So, okay. So, as we were talking, how this solar radiation flux varies throughout the year. Okay. So, it depends on which day of the year we are talking about. So that is given by the parameter n. Okay. So n is the basically nth day of the year, starting from Jan 1. So if you are going to calculate on Jan 1, then n will be 1, right? Similarly, on any day of the year, like say if you're talking about Feb 28, then it will be n will be 31 for the days in January, and plus 28. So on any day of the year we can calculate what will be the extraterrestrial solar radiation flux. Now we can see the one more parameter, ISC. So what is it? It is known as solar constant, because its value is a constant, which is equal to 1367 watt per meter square. And basically the significance of this parameter is, it is the amount of solar radiation flux received at the average or mean earth sun distance. So if this is sun, right, and this is your earth, right? So as solar radiation propagate from sun to earth, so at average mean distance, outside the earth atmosphere, so it's in extraterrestrial region. If we want to calculate how much solar radiation is received on a say a plane which is perpendicular to this incoming solar flux per unit time, then that value is this ISC solar constant. This is a constant value, right? And it varies. As this earth um, basically revolves around the sun, the distance between these two changes, and that parameter has been basically uh, incorporated by this n parameter. Okay, so on any n day on the earth surface we can calculate the extraterrestrial solar radiation flux. Hope this the significance of this, all the terms and parameter used in this equation is clear. So this extraterrestrial radiation, as we go from Jan to December, the curve follows this uh, basically nature. So this is basically talking about the northern hemisphere. So in northern hemisphere, this is the way the extraterrestrial solar radiation flux changes. Now, um, now how to measure this solar radiation over a period of time? So for that we have, because it majorly depend on what place we are talking about, which day we are talking about, which time of the day we are talking about. So there are several parameters that are involved while basically measuring the solar radiation. So for that we have some instrument also, and we have some empirical predictive equation also that has been derived considering several assumption, and we get some empirical relation. So we will first discuss about what are the instrument, and then we will discuss about what are the empirical relationship that we have already established to calculate the solar flux. So now, the atmosphere at Earth's surface could be cloudless or partially or fully covered by a cloud. So, depending on whether it is a clear day or it is a partially cloudy day, the solar now we have talked till now about till extraterrestrial region. Now, the solar radiation is entering the atmosphere. Now, here comes the factor of whether the sky is clear or not. So if we are talking about the clear sky, so if we are talking about at a particular location, so throughout the day this will be the variation of the incoming solar radiation. So in noon we have highest solar radiation coming at a place, and if we are talking about the partially cloudy day, then this curve is not so symmetric as we have seen here, right? So there is variation depending on which time the cloud is there or not, right? So this is one of the variation that might be on a particular day in a partially cloudy sky. Now, the type of solar radiation. So there are two type of majorly, or three type of solar radiation. One is direct, another one is diffuse, and third one is reflected. Direct is the solar radiation which is coming in a straight line, so it has not been deviated, scattered, or absorbed. That is directly coming onto the surface of the earth. Okay. Diffuse radiation is that radiation that has been scattered by the molecules and particles in the atmosphere, but still that has met down to the surface of the earth. So that is the diffuse radiation, right? And direct plus diffuse radiation is denoted by is cumulative term, we can say global radiation. Now, the third radiation type is reflected radiation. So, these sunlight or sun rays that has been reflected uh, of a non-atmospheric thing. So, it could be a surface of the earth. So, say the solar radiation has basically reflected off the surface of the earth and reaching to an observer, or maybe a PV cell or any application placed here. So these are the three ways solar rays can propagate from the after coming into earth atmosphere to the surface of the earth. Now we can measure this two value, the direct and diffuse value, by different instrument like pyranometer, paliometer, and sunshine recorder. So this paliometer only measure the direct rays. Pyranometer can measure both global and as well as the direct rays, and as well as the diffuse rays. Okay, so pilometer can measure the normal wave. This thing you have to remember which instrument is used to measure what type of radiation. Okay, and in the panometer we can directly measure the global horizontal radiation, and if we will blacken this surface, then we can also measure the diffuse radiation, and we know that global equal to direct plus diffuse, so we can calculate all the three parameters, right? So these are the things that has been already um, told in the lecture, so I will not go in deep into this thing. Okay, so another was a sunshine recorder. So basically the measurement is like we have a cardboard and the burnt traces of so we have this glass wall. Okay, so similar to what we used to do in our childhood, so we have a magnifying glass and we focus it onto a paper, and that paper burnt. So we, instead of paper, we have this cardboard, and here we have glass wall instead of magnifying glass. And as the okay, so as days proceeds, the bond trace proceed, and we can measure how much uh, sunshine duration we have received at a particular location. Now we can also use sensor, we can also use thermopile detector. Sensor basically we convert the generated heat into electrical signal, and then we can proportionate it and measure how much basically flux had been received. And this is the solar radiation data. Okay, so here it's generally solar radiation flux is one Langley is the unit, that is equal to 1.163 into 10 to power minus 2 kilowatt hour per meter square. So here in this slide various things has been explained about which region has highest flux and lowest, and that you can go through the lecture. uh, okay, you need to pay close attention to the units we are talking about. Okay, so if you're talking about instantaneous, global, and diffuse flux, so we have watt per meter square. If we're talking about hourly value, so it will be per hour. Okay, kilojoule or kilowatt hour per meter square per hour. If we're talking about daily, then it will be kilowatt hour per meter square per day. So pay close attention to what unit has been given in the question, and what unit the answer has been asked. Okay, so the solar radiation is influenced by the Earth sun distance that we have discussed, the relative tilt and time of the day. So irradiance and irradiation. So irradiance is basically the rate at which the radiation energy is incident on the surface per unit area of the surface. Irradiation is basically integration of it over time. So we are talking about um, in a particular time how much energy we have received per unit area of the surface. Okay, so that was lecture 4, and this is lecture 5, right? So in lecture 5, sir basically discuss about geometry, angles, and measurement. So okay, beam flux is coming at some angle, right? So okay, so beam flux and equivalent beam flux. So basically we are talking about the flux which is perpendicular to the surface. Okay, we are talking about this flux, this right. So if any beam is coming at an angle theta, okay, with the normal to the axis, we want a, what we are going to measure is the normal to the surface. So it will be IBN cos theta, and this cos theta will be the function of different angles that we are going to see. And so this cos theta term or this function of angle signify different angles that that shows the relationship between three things: the sun, the earth, and the observer on the surface of the earth. Okay, so this thing I will just explain later. So these are the different angle we'll discuss one by one. So the latitude and longitude basically gives the relationship between the sun, basically observer on the earth and the earth. So what is the position of observer on the earth? That is given by the latitude and longitude. So as we all know that latitude are the planes, lines perpendicular to the parallel to the equator, and longitude are the line perpendicular to the equator, right? So it goes latitude goes from basically your east to west, and longitude goes from your north to south, right? Now declination angle gives the relationship between the sun and the earth. So what is the angular placement of sun from the plane of earth equator? So if this is your sun and this is your earth, so if a beam radiation, solar radiation is coming, if we extend it to the center of the earth and take the angle of its angle from earth equatorial plane, so that gives your declination angle, right? So as so we know that the earth is tilted on its axis, right? So this also the in term of physical significance, you can understand that the equinox and summer solstice and winter solstice that we see, that is due to this declination angle. So it varies from 23 plus minus 23.45. Okay, so at basically if this is your line, okay, 0, so the declination angle between declination angle varies from 20 minus 23.45 to plus 23.45. So equinox is means we have equal day and night, and solstice means day is greater than night or night is greater than day. Okay, so if we talk about the northern hemisphere, then in summer solstice we have day longer than the night, and in winter solstice we have night longer than day, right? uh, uh, so uh, uh, so basically the equation that will be most probably given in the question, or if not, then this is the basic equation that you need to remember. So after practicing lot of question, this formula you eventually remember. Okay, so declination angle is given by 23.45 sine 360 by 365 into 284 plus n, where n is the number of day and day of the year, as explained earlier. Now our angle is due to if sun is we know that earth is also rotating on its own axis, and due to which the placement of sun across the sky changes throughout the day. So to basically incorporate that, the hour angle parameter has been divided. So it's such that in 1 hour the angle 15 degree, there is angular displacement of sun east or west of the local meridian. Okay, so if you're talking about so it is calculated from noon, solar noon. So note that it's solar noon. Okay, solar noon at 12 o'clock. Okay, so its omega is calculated from solar noon. So in 1 hour 15 degree angular displacement is there. So basically if we go for forenoon, then it's positive, and afternoon it's negative. So these sign convention you have to remember. It's when it's positive, when it's negative, and if we any time of the day we can calculate our angle for that. Okay, so depending on its forenoon or afternoon, it will be positive or negative. Now solar azimuth angle and inclination angle. So if this is a surface and this is normal to the horizontal surface, so uh, inclination angle, so if this is the incoming solar radiation, the angle between incoming solar radiation and normal to the horizontal surface is your zenith angle. Okay, this theta z is your zenith angle, and it's basically its projection onto horizontal plane. So the angle between incoming solar radiation and projection on its horizontal plane is your altitude angle. So these two angles, the zenith angle and altitude angle, are complementary. And if we take angle from this projection to due south, then that will be your solar azimuth angle. Okay, so hope this all three angles are clear. So okay, so it is positive when measured from south toward the east. So this way it's positive, and this way it's negative. We are talking about azimuth angle. Okay, these things you have to remember. Surface smooth angle is if surface is tilted, say at tilt angle beta, then normal to this tilted surface, if we project it onto the plane and take its angle from due south, then that will be your surface azimuth angle. So it's denoted by gamma. Note that the solar azimuth angle is denoted by gamma s, and the surface azimuth angle is denoted by gamma. Okay, so here are the few things that simplifies that will simplify your question. If mentioned the slope is toward the south, this means your gamma will be 0, right? If it's north, then it will be 180. If it's toward it east, then minus 90, west plus 90. So just to have understanding of this solar surface azimuth angle. Slope, as you know, that surface might be tilted. It's not like we are always going to talk about the horizontal surface. So the tilt that we have for surface is denoted by beta. So beta could be from 0 to 180. So these are all angles combined together. So if you can see, this is the surface, uh, be, uh, and it's tilted at angle beta. So beta is your tilt angle. This is normal to the horizontal, and this is normal to the inclined surface, and this is the incoming solar radiation. So just to understand all the angle in one picture, you can see that the from solar radiation to normal to the surface is your zenith angle, and solar radiation to its projection on horizontal surface or to the horizontal surface is your altitude angle, and this projection to due south is your solar azimuth angle. Now from the normal to the inclined surface, if we measure, then this is the theta that we are going to calculate. Okay, so incoming solar radiation to normal to the inclined surface, this theta we are going to talk about in whole upcoming lecture series. And uh, and its projection onto a horizontal plane, if we take its angle from due south, this will be your surface azimuth angle. Now this theta is function of all these angle, and how it is function, that is a derived thing. Sir has explained few of its derivation in the lecture series. We'll just go to question and understand how its application is. So this is the formula. This formula you need not to remember. This will be probably given in the question, or it will be given in the question. Just you need to understand the significance of each of this angle, so you can simplify this whole long equation into short form. That will we will see how it will be done in upcoming slides. So just so vertical surface means beta equal to 90, horizontal surface beta equal to 0. Beta is the tilt angle. If we're talking about inclined surface facing due south, so your gamma will be 0. If vertical surface facing due south, vertical surface means beta will be 90. Due south means its surface azimuth angle is 0, right? So by putting this parameter into the equation, values into this whole equation, we can simplify and get this uh, shorter version of this equation. Now sunrise, sunset and day length. So this is the derivation that sir has explained in the lecture. You can go to the lecture. What you need to remember is uh, this thing, that 50 degree of hour angle is equivalent to 1 hour. So in 1 hour, we have already discussed this point earlier also. So based on this point, we have got this equation, that you need to remember that our angle is calculated by cos inverse minus tan delta tan phi, and based on this hour angle, so we can calculate the duration of sun sign hour td, which will be 2 by 15 cos inverse minus tan delta tan phi. So these are the important formulas that you need to remember, right? So this was the second lecture, and the third lecture in this module was this. Okay, so we have already seen sunrise, our angle on, just a minute. Okay, our angle on horizontal surface given by this equation, day length given by this equation. So note that as we have discussed earlier, all angle will be positive forenoon and negative afternoon. And if you're talking about inclined surface, so this was on a horizontal surface, right? In inclined surface, uh, we have we will now incorporate beta, the tilt angle, into this equation. So these are all the empirical relation. uh, so if you're talking about days like between, so this you need to keep in mind somewhere. Okay, so uh, between September 22 to March 21, if you're talking about northern hemisphere, then this formula will be same. And if you are talking about in March 22 to September 22, then just we have to incorporate this beta parameter into the equation. Okay, so phi will be phi minus beta. Note that phi is your latitude angle, right? And delta is your declination angle. Omega is your hour angle. Okay, and if you don't want to remember this, this is the thing that minimum of this two parameter you will report as your answer. Okay, so this was the example that sir has told in the lecture. You can watch, go and watch back this explanation. Huh. So this is another important parameter, solar time. So significance of this solar time parameter is it basically uh, basically gives a numerical value to basically specify what is the position of sun in the sky with the passage of time. So whatever standard time that we know, so standard time depend on specific time zone. So for India we have IST, Indian Standard Time, that is based on the your that is defined for the meridian passing at Allahabad, right? Prayagraj. So for that has defined the whole time zone. So the because in whole India we can see we run on a same time. It's not like we have different time in UP and we have different time in Maharashtra. So that is the standard time. Okay, so the solar time or local time is different from the standard time, where we incorporate two parameters, two major parameters. One is this: what is its difference between longitude of that location and the meridian on which the standard time is based. So for India, say the standard meridian is passing through Prayagraj, and if you are talking about um, say Guwahati, right, the sun rises earlier, right? So this is due to though the standard time is same, the solar time will be different at both of these location. That is basically incorporated by this term. So for each 1 degree change in the meridian, 4 minutes is added or subtracted from this standard time. Now whether it will be added or subtracted, that depend on which hemisphere we are talking about. If you will go to the eastern hemisphere, it will be negative, and if you will go to the western hemisphere, then it will be positive. So this is the I hope this parameter is clear, right? Now there is equation of time correction. So since the earth is earth orbit fact that the earth orbit and rate of rotation are subjected to small variation. So for that we have incorporated this E parameter, which is equation of time correction. And this E is a function of which day of the year we are talking about. So again it's function of the n. So based on n you can calculate this B parameter, and we can put back this B parameter into this equation of time correction factor, and we can add it to this standard time to get our solar time. So I hope the significance of each term is clear, and this formula you need to remember how to calculate the solar time. Okay, solar time, this formula is important. And this bigger formula will be given in the question, maybe this will be also given in the question, but it's better to remember this. This is simple: L minus 1 into 360 upon 365. Okay, So if we talk about comparison between local time and standard time, so local time is defined on the apparent movement of sun in the sky. Standard time is fixed for places falling in the same meridian. Okay, so it standard time remains same for the particular country, and local time changes with change in the longitude. So this thing we have explained just explained earlier also. Now, if you want to calculate the solar radiation for a whole month, so rather than calculating it for each day, what uh, it has been done is we have defined a day in a month as an average day of the month. So, if we calculate solar radiation on this particular day, it will be equivalent to the solar radiation for the whole month. So for January it's 17 January, for February it's 16th Feb. So so and will be your I depending on which month we are talking about, and will vary, and particular. So this table signify just that uh, that you can basically calculate uh, a whole month solar radiation based on an average day of the month, and this is the fixed parameters. Okay, so this you need to, I don't think you need to remember, just this thing if you can keep in mind. Okay, now sir has explained this. Okay, so I will just quickly go through the concept behind this question. Okay, so determine the angle of incidence of a direct irradiance solar radiation on an inclined surface at 45 degree from the horizontal, with orientation of 30 degree west of south, and located at Mumbai. The latitude is given, longitude is given, time is given, date is given, and the standard longitude for India is also given. Right. So first, as soon as you see the equation, you need to quickly identify what are the parameters that has been given in the question. So inclined surface is tilted at angle 45 degree. So beta is your 45 degree, right? Now the orientation is 30 degree west of the south. So if this is north, this is south, this is east, and this is, here is west. So we are talking about west of the south. So we are talking about this direction, right? And uh, basically your phi is given. Okay, your latitude is given. Based on this, you can calculate time given. You can calculate omega also, and and day of the year you can calculate December 15. So from starting from January 31 plus 28 plus 30, so on to December 5th, you can calculate the n number. Now standard latitude is, longitude is also given. So these are the parameters given in the equation. Now the formula that we know, based on n we can calculate the declination angle, right? And based on the n also we can calculate uh, b parameter, that we can just, we have to think in a way how to basically approach a question. So based on what parameters are given in the question, what parameter we can calculate from that. Okay, so we have to pay attention, we have to think in that way. So based on that we can calculate e, right? And this is the final thing that we have to focus on, right? This is the final thing. So in this we what parameter we should know is declination angle, this is latitude, declination angle, slope, and your azimuth angle. So these four parameter, also your hour angle. Okay, so these five parameter you should know. So declination angle you can calculate based on the and day of the year. Beta is already given in the question for 45 degree, I think, right? Omega you can calculate based on the time here given. Okay, and azimuth angle is also given in the question. Now this is the solution to the question. So here note that how you convert this, like 81 degree and 44 minutes are given. So how this will come if you have doubt. So it's basically for 81 plus 44 by 60. So basically you are converting minutes into degrees. So 44 by 60 you will get this value. Okay, So you can calculate delta, you can calculate declination angle, latitude, you can already given in the question, beta already slope given in the question, 30-degree azimuth angle already given in the question. To calculate the omega, right, our angle, first you need to calculate the solar time. So for solar time, you already know the formula, you will put all into the equation, you will get your hour angle, and after putting all this parameter into this big equation, you will get the value of theta that has been asked in the question. So I've just explained how to approach a question, right? uh, okay, the last part is this sun path diagram. So sun path diagram are used to define what position of sun is with respect to any geographical location on the earth. So if you want to calculate at any place, at any day, at any given time throughout the year, what is the position of sun in the sky, then you can use this sun path diagram. So it's very useful diagram that has application in several solar thermal devices. If you are going to install the solar panel, so what should be the optimum orientation of this solar panel? uh, that you can basically this sun path diagram is used for that. Or you want to see whether shading is if you are going to basically install any solar thermal energy devices, whether it will be shadowed depending on what is the position of the sun in the sky. The shadow of the maybe the equipment involved in that setup, or the equipment or the buildings beside that particular setup, how its shadow will vary throughout the day, that can also be estimated by this sun path diagram. So that is the application of this sun path diagram. Okay, so it's basically give the location of sun in the sky in term of two angles. So solar azimuth angle and solar altitude angle. So these parameter we can get from sun path diagram to know what is the exact position of the sun in the sky. Now this both parameters or the angles in terms function of different various angles that we have discussed. So like latitude angle, hour angle, declination angle. So if just to give you an example, if this is your sun path diagram, okay, so the perimeter of this circle have the azimuth angle, okay, and this basically your axis, the perpendicular lines, this basically vertical line is your altitude angle. Okay, your sun path diagram is this, the curves you see here, and the basically the lines you see here. So we have two lines. So it will be more clear if I will explain in this diagram, the Cartesian sun path diagram. Okay, so basically we get from sun path diagram altitude angle and azimuth angle. So we have two lines, two curves. One is the day curve and one is the hour curve. So basically this line that you see is the day curve. Okay, which day of the year or which month of the year we are talking about, and these line are the hour line. Okay, these line are the hour line. So depending on starting from midnight to 6 a.m. to your noon to your basically uh, sunset. Okay, so what we have to do is, for a particular day, say if you are talking about any day in the Feb, okay, for particular day in the Feb, uh, at a particular time, so say at 11 a.m, we are, so we'll see what is the intersection of these two curves. These, this will be our point. So we have to note this point, and corresponding to this point, we'll draw perpendicular on the x-axis and the y-axis. So the perpendicular on the x-axis will give you the azimuth angle, and perpendicular on the y-axis, say here, will give you altitude angle, right? Basically this sun path diagram is most commonly used, so I have explained in this sun path diagram only. Hope this is clear how to calculate azimuth and altitude angle from a sun path diagram. Okay, so sun path at different location varies. This you can go back to the lecture and we have quickly wrapped up the lecture series. Now, what I will do is I'll give you some question, and as usual, uh, I will give some time for you to uh, answer that question in the chat box, the option to that question, and then we'll discuss the answer in detail. Okay. So this was the question that we discussed in the last class. So I've included the solution to this question here. So just for your reference, that because I will upload this PPT online. So on the basically link that has been shared with you. So if anyone has doubt, you can go back to the solution to this problem. Now for this session, the first question is, how is the latitude of a location on Earth defined? So you can write your answer in the chat box. Which option do you think is right? Am I audible? You can just write in the chat box because I'm not seeing any answer and it's like, am I audible? Okay, Alok, you can just unmute yourself and speak.
Yes, 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 madam. You are available.
Okay, okay, fine. So you can all answer for this particular question in the chat box. Okay, I've got just one answer, which is answer B. Okay. So anybody else want to answer the question? So this we have just discussed. Okay, we'll straight ahead discuss the answer to this question. So the correct answer is answer A. So as discussed in the question, in the just few minutes ago, latitude of a location on the earth, so it basically determines the relationship between the observer on the earth and the earth. So if this is your earth, this is your equatorial plane, right? And say we are talking about, so just to have, so this is your equatorial plane, and you are talking about a person P here on the surface of the earth. So the latitude angle is basically if you join this line, basically location to the center of the earth, and, and if you take this angle, the earth equatorial plane, so this is earth equatorial plane, and this is the point P, or the location of earth we are talking about. So the angle between the line joining the observer or the location to the center of the earth and the earth equatorial plane, this is the latitude angle. Okay, this is latitude angle. So the correct answer for this question is option A. Hope this answer is clear, explanation is clear. Now the second question is very simple question. The line joining north and south pole of the earth are called. Okay, we have got one answer. So okay, Vivek and Shashank has opted for option B. Anyone else? Okay, we'll discuss this answer. So the correct answer is answer B only. Okay, so this is the earth, this is north, this is south, this is east, this is west, and the line joining from the north to south, these line, and this is your equatorial plane, right? So these line are called longitude, lines of longitude. Okay, and these are semicircle because they run along the curved surface of the earth. So yes, so these are parallel to the line passing through the Greenwich, which is known as prime meridian. Okay, so prime meridian is also a line of longitude. Now, so this is the question. Next question: the zenith angle is the angle made by sun's ray between which and which surface? Okay, so most of you have opted for option A. Okay, so let's discuss the answer. So option A is correct. So the zenith angle, if you're talking about a surface, horizontal surface, and this is your normal perpendicular to this surface, and a solar beam is coming. So the zenith angle is angle by the angle made by the sun's ray with the normal to the horizontal surface. So this is your horizontal surface, this is normal. Okay, this angle is your zenith angle denoted by theta z. Now the altitude angle is the angle between which? Okay, we have only got one answer. So Vivek has answered for option B. Anyone else? Okay, let's discuss this question. So the correct option is option A. So what was the altitude angle? So if this is the horizontal surface we are talking about, this is the normal to the okay. So this is the horizontal surface, right? This is normal to the horizontal surface, and this is the incoming solar radiation, okay, from the sun. So altitude angle was the vertical angle. So if you project this solar radiation onto the horizontal plane, so say this is the projection. So the altitude angle is the vertical angle between the projection of sun rays on the horizontal plane of the surface. So this was your altitude angle, right? So this was your, I think it was denoted by this, and this was your zenith angle. So these two are the complementary angle into the vertical plane, right? It's not a horizontal angle, it's vertical angle. Hope this angle is clear. Now the next question is, what is the altitude angle at the altitude angle is maximum at noon? So is it true or false? This statement is true or false? So let's discuss this question also. So the question is asked that whether the altitude angle is maximum at noon or not. So is it true or false? So Vivek has answered true. So let's see. So this option is correct. So altitude angle, as explained just now, that this is your perpendicular to the surface, right? Normal. This is incoming solar radiation, say. Now at noon, the sun is here, right? At zenith point, right? So now the solar radiation direction is this, right? So your altitude angle will be this. So it will be maximum, right? So it will be maximum 90 degree at the noon. So So altitude angle talks about how high the sun appears in the sky. So at noon, maximum, it is maximum at noon, which is 90 degree. And if we'll talk about the sunrise and sunset, so say this is sunrise, say 6 a.m. and 6 p.m., right? So the rays might be coming here, like in this direction. So the uh, in that case, the altitude angle will be 0 for the sunrise and sunset case. This is the talking about noon, right? Hope this altitude angle concept is clear. Now, coming to the next question, what is the range of sun's declination angle throughout the year? Okay, we have got the major vote for option C, right? So the correct option is also option C only. So as so if this is the sun and this is your earth, slightly tilted on its axis, right? So as this earth revolves around the sun, this declination angle changes, right? So this, if this is your equator, this is topic of Cancer and this is topic of Capricorn, right? um, so what happens is this declination angle is determine the tropical range. So this tropical range is determined by this uh, declination angle only. So the uh, the topic of Cancer is basically this range is set by this declination angle only. So uh, uh, so throughout the day of the year, the maximum range uh, uh, through which the solar radiation is receiving on earth perpendicularly to the like earth surface, that is given by the declination angle. So if this are the equinox, right, and say this is summer solstice and this is winter solstice, right? So in summer solstice, the sun basically falls perpendicularly to the tropic of Cancer. So this is plus 23.5 degree. And in winter solstice, we are talking about the northern hemisphere. So here sun rays falls perpendicularly on the topic of Capricorn. So this is minus 23 point. It's actually 4.5 or 5 degree. So this is the range of declination angle from plus to minus 23.5 degree. Hope this is clear. Okay. So coming on to the next question. The angle made in horizontal plane between the horizontal line due south and the projection of normal to the surface on the horizontal plane. What is this angle called? Okay, I'm not seeing any answer to this question. Since we have not much time left for this session, I will quickly discuss this question because we have some numericals ahead. So that will require more time. So the correct answer is the option B, surface azimuth angle. So if this is the surface we are talking about, right? So this is east, west, west, north, south. This is perpendicular to the surface, normal, and this is the incoming solar radiation, solar beam, right? So the angle made in horizontal plane between the horizontal line due south and the projection of normal to the surface on the horizontal plane. So if we take projection of this normal to the surface on the horizontal plane, so this is the projection. So the angle between these two is surface azimuth angle, right? So denoted by gamma. So hope this option is clear. This answer explanation is clear. So this is also quick question: how our angle is measure of time of day with respect to solar noon? Is it true or false? Okay, it's okay if you don't know the correct answer. You can just guess the answer. What seems to be true? Like, what could be the possible answer? Okay, I will repeat the question, Vivek. So, this question is talking about the hour angle. So, whether hour angle is measure of the time of the day, what is the time of the day with respect to solar noon? So, is this statement true or false? Okay, so Vivek has opted for option A, true. Okay, which is the correct answer. So, hour angle is basically we calculate with respect to solar noon. So, if this is your solar noon, so our angle is measured from solar noon, whether we are talking about forenoon or afternoon, so it will be positive and negative, right? So we have also discussed that 1 hour 1 hour so earth rotation is equal to revolution is equal to 15 degree, right? This is the important uh, parameter or thing to remember. Now, this question is so I have some theoretical question. I think 2 3 left, so we'll quickly discuss this question so we can discuss numerical in detail. Okay, so which of the following best describes the working of thermoelectric pyranometer? Okay, we are getting some answers. So Shashank and Vivek has opted for option B, and Sunny has opted for option D. Okay, so the correct answer is option B. So as we are talking about pyranometer, right? So it can measure both the global and the diffuse radiation, right? So how it is measured is the solar radiation is falling on a thin black surface. So we have some setup like this. So this is the black surface. Solar radiation is falling on this black surface. Um, there is rise in temperature, and as it attain the thermal equilibrium, then corresponding thermal EMF can be measured. So option B is correct. Now, how does a sunshine recorder work? You can write your answer in the chat box. So Vivek has opted for option C. Shang opted option D. Okay. Again option C. Okay, let's discuss the answer. So basically, the sunshine does record the number of hours of sunshine, but above a certain threshold. Okay, so that threshold is typically set at 200 milliwatt per centimeter square, and the data collected can be used to determine the solar insolation. So it's not like if it's a cloudy day and the sunshine is way below this threshold, then it will not burn. It will not leave the burnt traces on the cardboard, right? So, uh, so it has to be above certain threshold. So that's why option D is correct. Uh, Hope this is clear. So obviously this method is not very accurate, but it's a very inexpensive method. Okay, so that's why its application is there. Now, this question, which of the following is the simplest sundial? If you want to know the position of the sun in the sky, so it's just a general, like, the question like what could be the simplest sundial? So we are getting option A. So that is correct. So if we have a tall pole and its shadow, depending on how its shadow is casted, we can also determine what is the position of the sun, right? So based on the what is the length and position, we can determine. So it could be a very practical application of a sundial, right? So uh, for 1 degree change in longitude, the change in solar time is. Any guess for this question? So let's discuss this question quickly. So for 1 degree change in longitude, the change in solar time is 4 minutes. So if you remember the equation to calculate the solar time, basically it's solar. So if we will calculate solar time equal to standard time plus minus your 4 into standard longitude into your place, whatever your place longitude is there, and plus e. So this parameter was incorporated considering that with each degree change in the longitude, we will add 4 minute or add or subtract 4 minute to it. So the correct answer for this question is 4 minute. Okay. So So this is the next question. On June 22, the declination angle will be. So Shashank and Sunil is opted for option A, 0. Vivek is opted for option B. So let's discuss the answer. So the correct option is option B. So if you remember, uh, you can calculate it numerically also. So for June 22, you can calculate the end day of the year. So 31 plus 28 plus 31 plus 30 plus 31 plus 22, and we can put it back into the equation. 23.45 sine 360 by 365, 284 plus n. You can put this number into and value into this equation, and you can get the value. Or if you remember, June 22 is your summer solstice, right? So on that day, it will the sunrays will directly fall perpendicularly on the topic of Cancer, which is plus 23.45 degree, right? So this is the summer solstice is June 22, winter solstice in northern hemisphere is December 21. So these are the thing that you can keep in mind to save your time. Okay. Now, this is the first numerical question. Calculate the number of daylight hour, sunshine hour in Srinagar on January 1st and July 1st. The latitude of Srinagar is given. Okay, anyone who is approaching to the answer for this question? Okay, let me discuss the concept behind this question and the calculation part. You can just check whether you are thinking in the right direction or not. The calculation part you can do it later also, right? So, uh, what's asked in the question is number of daylight hours. Okay, sunshine hours in Srinagar on January 1st and July 1st, given that the latitude of Srinagar is given. So what we have, so first we have to note down what parameters are given in the question. Uh, so we have two cases. So we have January 1st, right? And we have July 1st, right? Now we what else we have given? The latitude of Srinagar is given, which is 34 degree 5 minute north, right? So uh, for January 1st, the nth day of year will be 1, and for July 1st it will be 31 for Jan, 28 for Feb, 31 for March, 30 for April, 31 for May, 30 for June, and for July we have 1. So we can add this value. Okay. So whatever value we'll get, uh, next from and what we can calculate is declination angle, which will be 23.45 or 23.5 sine 360 by 365 to 84 plus n. We can put this n value into this equation and calculate declination angle for these two days, right? And and we have 5. Now if you want to calculate the number of daylight hours, so number of daylight hour is given by 2 by 15. So I'll just, okay, so just a minute. So hope this process is clear. Okay, so note that the 34 degree and 5 uh, minute will be converted into degree by 34 plus 5 by 60. Okay, so this will come into 34 point something in degree, right? So this is how you approach the question. um, okay, now, so I don't know if you can see or not. I just given, so the delta for one Jan 1 will be minus 23.01, and for July 1 will be 23.12. Okay, and you can declination angle you got, you can put in this equation 2 by 15 cos inverse uh, minus tan of this phi and tan of delta. So this is the equation to calculate the del n. So you know the delta, you know the phi, you can put back into this equation and you can get on January 1st you have 9.77 hour of daylight sunshine hour, and on July 1st you get 14.24 hours of sunlight. So hope the how to approach the question, how to identify what's given in the question and what you are aiming for, what formula you have to remember, that part is clear, right? I'll provide the solution in the lecture slide also, which will be uploaded. So you can, if you have any doubt, you can go back and refer back to it. Is this question clear? Any doubt right now in this question? Okay. So moving on to the next question. So this is the similar question. Number of daylight hour in Guwahati on January 1st and July 1st. Uh, so the latitude of Guwahati is given. You can try back later. Uh, so since the pattern of this question is similar to the previous that we have discussed, the correct option is given. We'll quickly go to this question. So for New Delhi, okay, the latitude and longitude are given. Incidence of solar radiation is observed at 2:30 p.m. on 20th Feb. The standard longitude for India is given. What is the solar time at this particular 2:30 p.m. time and on 20th Feb? Okay, the option is already visible. Okay. Okay. So since we have only 7 minutes left and the answer is also visible on the screen, what I will do is I'll quickly explain the concept behind this question. Okay. I'll just give 2-3 minutes for the first part of the question. If anyone wants to try and see whether the answer they are getting is correct or not, then I will discuss this question. Anybody has got the answer to this first part of this question, the solar time? Okay, let's discuss this question. So we'll first note down what's given in the question. Okay, so the location is given. So corresponding to the location, we have the latitude and longitude. So we have the phi and we have the L, right? We have also given the time of the day, right? And we have also given the date. So from the date, you can calculate the end day of the year, and from the time, you can calculate the omega, right? The hour angle. Standard longitude of India is also given. So what's given is standard value of longitude for India. Now we have been asked about the solar time at 12:30 on 20th Feb. So we know that the solar time is given by the the standard time, right? Plus we are incorporating the change in time that will be occur due to the difference in the longitude of that particular location to the standard longitude, right? And plus your correction factor E. Now we will focus on this is already given in the question 2:30, right? This is also given in the question, this is also given in the question. uh, what we have to calculate is this parameter E, the correction factor, and this is E is the function of N, right? So the if we'll focus on this part, okay. So uh, E will be first we'll calculate the B will be N minus 1 upon 360 into 365, I think, if I'm not wrong. So this 365, 360 into 365. So based on this B, we have uh, a long equation for calculating E. We will calculate E. We have all the parameters uh, required for calculating the solar time. We'll put all into the this formula and we'll get the solar time, which will be uh, when we'll solve it, it will be option A. Now coming to zenith angle. So what's been asked in the question is theta z, and we know the formula for cos theta z, which is function of all the different type of angles we are talking about, right? So the big equation that we have now, this is the function of uh, your um, latitude angle, your hour angle, your declination angle, and what. So this is all function of all this. Cos theta is function of the all this angle. We have that big formula. So from n we can calculate delta, right? And from based on the solar time that we have got, we can calculate the omega, right? So for each hour we have, for 1 hour we have 15 degree, right? Correspond to 15 degrees. So based on that, we can calculate the hour angle. So we have hour angle, we have declination angle, we know the latitude angle, and so this is cos theta. So it's cos theta z. Theta z is your zenith angle. So this is the formula I was talking about, right? So it will be your cos phi. This is phi. This is your delta, and this is your omega, right? We'll put into the equation. You can finally get the zenith angle from it. Note that uh, since uh, the time is up, so what I want to give a suggestion here is, if you want to go deep, like you can follow the lectures, you can follow the lecture slides that has been uploaded on the portal. If you want to go deep into an understanding of this whole angle, uh, you can also read the Sukhatme and Naik solar energy book. So if someone wants to read a book, so you can refer to that book. And Also, there might be some notation. I'm someone has okay, fine. So you can follow
Okay,
Suparna and I will solar
okay,
energy.
madam. One thing I want to ask here. In the
Right,
examination, what type of in the examination,
right.
what sort of questions you will get? You will get this type of questions, or it is a multiple choice, or what type of questions you will get in the examination on November 2nd?
So basically, all question will be MCQ type. Then the second thing is it could be a like theoretical question as discussed here or numerical question. Okay, so it could be both. So mainly numerical question will be there. So whatever is been discussed in the lectures, whatever discussed in the live session, you have to pay close attention what has been asked in the assignment. So the question will be framed similar to what has been discussed in all these three. If
Today I joined late, so I could not go through the questions you told. I joined late, so can I have a glimpse of those questions what you discussed?
sure. Actually, this video will be uploaded on YouTube, and the link to that YouTube lecture will be shared to you all. So I will upload both this
No,
video
this
lecture and this
problem
presentation slide.
solving, no, problem solving session, this 2 hour session, will it be uploaded?
It will be also uploaded on YouTube. So the link to that YouTube lecture will be also provided to you in addition to the slides that has been discussed in this lecture, in this live session. Okay. So you don't need to worry.
And those things are those things are there that I have already gone through, but your 2 hour session that I am not finding anywhere. That link I am not finding. Your session
So
2 hour lesson. Last time and this time also. For
okay,
session
just
one
let
or
me show
session
you
two.
from where you can get it. So if you'll go to the your Swayam portal, right? So this is how your Swayam portal will look like. So for here you can see the problem solving session July 2024 is there, right? If you click
Okay.
on this, you can see the problem solving session recording. Okay, so if
Okay,
you
okay.
click
It
here,
is not coming in the screen. In the screen, it is not coming, madam.
okay, well,
Okay.
just a minute. Okay, let me share. Let me
Yeah,
first
yeah,
stop
that is
sharing
nice.
and
Yeah.
then I will. Okay, just a minute. Um, okay, okay, is my screen visible? Uh, is my screen visible?
This screen is visible.
Right.
A problem
So
solving session record.
okay. So this is your Swayam portal, right? So if we'll
Okay.
go in the end of this thing, so there is some
Okay.
problem solving session, right? So if we'll click on this
Okay.
problem solving session recording, we'll be directed to this link. Okay.
Okay.
So this is the Excel sheet where the YouTube link weekly will be uploaded. Like we each 2 hour this live session will be uploaded weekly here, and the drive link to the basically the slides that has been shown in this 2 hour live session you can access from here
Okay. Is it, it will be there for how many weeks? For up to the exam?
up to the exam.
Or it will okay. For week one, it is there.
It's for week one. You can already see the YouTube link has been
Okay,
provided here,
week one.
and if
Okay,
you click
okay.
on this, then a drive will open, so you can access the PDF for the slides that has been shown in this live session here. Okay,
Okay, madam. Okay, madam. Thank you. Thank you.
that's fine. If you want to suggest any feedback, whether I should, then feel free to suggest any feedback. If you want to have the the discussion session about the lecture brief, or if you directly want to solve more numerical question, feel free to let me know. Okay, I will just tune according to your requirement. And hope this session was useful to you. If
Definitely, madam. Definitely, it's very useful.
Okay, thank you for listening. If you have any query, feel free to ask on the SWAM portal, and or in the next
Can we,
upcoming
madam,
section.
one thing, can we have sample paper for that examination? Can we have sample papers? If she
Sample
is not
paper.
available.
So
Yeah.
uh, I don't know. Uh, I think the assignment question that has been asked weekly, and
No,
the
that we
question
are
discussed in
submitting.
this. I don't think you
That
can
we
get the sample paper for this course. Okay, so for
okay,
the
okay.
final, the test that you take.
Uh,
It's my role here to provide you the question similar to what has been asked in the assignment and what will be asked in the your final examination. So
yeah.
these questions are
Okay,
similar to
madam.
what will be asked.
Okay, madam. Okay, madam. Okay, thank
Okay,
you,
okay.
madam.
Thank you for listening. We'll see you in the
Okay,
next live session.
okay, madam.
I'll end the session now. Thank you all.